In the world of modern technology, speed and responsiveness are everything. But how do apps actually keep up when millions of people click buy at the exact same time? Welcome to the complete visual guide to event-driven architecture with Azure. This isn't just a technical lecture, it's your blueprint for building software that's faster, smarter, and ready to scale. Over the next few minutes, we'll strip away the jargon to reveal the three musketeers of messaging, explore professional blueprints like pub/sub and CQRS, and show you how to conquer real-world challenges like event storming. Whether you're a developer or just curious how the digital world moves so fast, stick around. By the end of this course, you'll be building systems like a pro. Let's dive in. Imagine a world where your technology is as responsive as a conversation. When you click Buy Now, a chain reaction begins. In traditional systems, this was like a line of people waiting for each person to finish a task before the next could start. If one person tripped, the whole line stopped. We call this tight coupling. But with event-driven architecture, or EDA, we break those chains. An event is just a digital signal that something important happened, an order placed, a sensor triggered, or a new message. Instead of waiting, a producer simply shouts the news into the void. Meanwhile, consumers, like your bank or the warehouse, listen for that specific shout and react instantly. Because these parts are loosely coupled, they don't need to know each other exists. This allows you to add new features like a rewards program without touching your original code. It's the secret to building fast, flexible, and resilient systems on Azure. Meet the three main characters that make an event-driven system work. First, we have the event producers, the originators. Think of a motion sensor in a smart home. It detects a change and packages it into a data bundle, essentially saying, something happened here. Next are the event brokers, our essential middlemen. A producer doesn't talk directly to a consumer. Instead, it hands the message to the broker. The broker acts like a traffic controller, filtering the noise and ensuring the message reaches everyone who needs it without getting lost. Finally, we meet the event consumers, the doers. They sit quietly, listening for specific signals. When the light bulb service receives that motion-detected event from the broker, it springs into action and turns the lights on. By splitting these roles, your system stays organized, efficient, and ready to scale. To build professional systems, developers use specific blueprints called patterns. First up is publish-subscribe, or pub/sub. Think of it like a newspaper. A producer publishes a message to a central topic, and thousands of different subscribers can read that news at their own pace. It's the ultimate way to share information across a huge network. Next, we have event sourcing. Instead of just saving your current bank balance, the system saves every single deposit and withdrawal that led to it. This creates a perfect audit trail, essentially allowing you to rewind time to see exactly what happened and when. Finally, there's CQRS. This pattern splits your workload into two paths, one for commands that change data and another for queries that read it. By separating these responsibilities, you can optimize each side independently, making your system incredibly fast. These patterns are the secret to building resilient, high-performance architectures. To build professional systems at scale, developers use specific blueprints called patterns. First, we have publish-subscribe, or pub/sub. Think of it like a newspaper. A producer publishes news to a central topic, and thousands of subscribers can read that same message at their own pace. It's the most efficient way to broadcast information to many different services at once. Next is event sourcing. Instead of just saving your current bank balance, the system saves every single deposit and withdrawal that led to it. This creates a perfect audit trail, essentially allowing you to rewind time to see exactly what happened and when. Finally, we have CQRS. This pattern splits the workload into two distinct paths, one for commands that change data and another for queries that read it. By separating these responsibilities, you can optimize each side independently, making the entire system incredibly fast and responsive. These patterns are the secret to building high-performance, resilient architectures. Even the best systems face real-world hurdles. First, there's event storming. Imagine a Black Friday sale where millions of clicks happen at once. Your system can get overwhelmed. To fix this, we use throttling to slow the flow to a manageable speed, or scaling, which automatically adds more virtual computers to handle the extra load. Then there's the issue of duplicate messages. In a busy network, an order might be sent twice by mistake. We solve this by building item-potent consumers, services smart enough to recognize they've already processed a specific ID and simply ignore the second copy. Finally, because events fly across many different services, finding a bug is like finding a needle in a haystack. We use a Correlation ID, which acts like a tracking number on a package. By following this unique tag, you can see exactly where a process failed. Mastering these challenges is the key to building reliable, high-speed applications on Azure. In this journey through event-driven architecture, we've transformed how we think about building software. We started with the basic flow, producers shouting news into the void while consumers listen and react. We met the Three Musketeers, producers, consumers, and the all-important brokers who act as traffic controllers to keep data moving safely. We then leveled up with professional blueprints like PubSub for broadcasting, event sourcing for a perfect historical audit trail, and CQRS for high-speed performance. Finally, we learned to conquer real-world hurdles using throttling for traffic spikes, idempotent consumers for duplicates, and correlation IDs to track down bugs. With Azure's toolkit and these patterns, you're now ready to build systems that are fast, reliable, and ready for anything.